Hello class and welcome back to CSC 151, Computer Applications. This is going to be the first of our follow-along assignments. So what is a follow-along assignment? It is what it sounds like. I will be, in this video, making an assignment from scratch, from beginning to end, live in this video. And you will be following along. And at the end of the video, you should, in theory, have a fully functioning, working assignment that, because you've been following along on, you'll get a 100% on. Now then, if you by any chance need to pause the video to, work on stuff and then pause, unpause, pause, unpause, go ahead and do that. Now, I am currently in apps.diagram.net, or if you want to, draw.io. It'll lead us to the exact same place. Now, you'll notice I currently have this thing saying CSC 151 D Montecchio class example.draw.io. I did that in a previous video that the dog ruined by going into File, Save As. And I can change the name of it. By default, these things are labeled Untitled 1, Untitled 2, Untitled 3. I don't want to see Untitled 1, Untitled 2, Untitled 3, Untitled 4. It gets very difficult figuring out whose is what assignment. So, general rule of thumb for naming conventions. First and foremost, make sure you have one word. That's why I have these underscores. The minute you add spaces into a name, a file name, depending on the program, the computer will treat that as two different files, and that will cause a lot of problems. So, one word. Also, make it a word that makes sense. As this is CSC 151, I made sure to put the class title in there. As this is my work, I put my name in there. As this is also the class example, I put class example in there. So if your name is by any chance Bob Smith, and this is the, tic-tac-toe, maybe you want to name this something like CSC 151 underscore B Smith underscore TTT for tic-tac-toe. Some sort of naming convention of some sort that makes sense to you. Because I don't want to see untitled. I don't want to see the words untitled document anywhere in this. The other thing you would like to know is that the .draw.io is actually needed. That is what tells me that it's an XML file. Okay? So, that's how that winds up working. So if I want to do an editable bitmap image, a .png, that would be that. An editable vector image, a SVG, it would be that. So if I have something that's a .jpg, that's telling me the file is a JPEG. If I have something that ends in .html, that's telling me that I have a hypertext markup language file. If I have, a .py, that's telling me it's a Python file. If I'm seeing, docx, that's a Word document, so on and so forth. So whatever that extension ends with tells me what type of file it is. And I wound up saving this down to my device, which is literally my computer. And I can prove that by going into File and Open, and I can open from my device once it feels like loading. And there's some examples. There's my downloads over there. There is my CSC 151 example currently as it is. Upload. And I'll just open this in this window for the time being. Yeah, I don't care about the changes, discard it. And that's basically what I have right now as my file. My file is literally just telling me that this is a tic-tac-toe flowchart by David Montecchio. Word of advice, don't just put your name in the file, put it on the file itself as well. Put your name on any page you work on. I guarantee it will help you out. I would like to be able to know whose work is whose. It will also help prevent people from trying to steal work from you. Because I have found out numerous occasions, if you put your name in 2 to 3 places, people don't really realize that there's the name in 2 or 3 different places. So it's much easier to catch when someone tries to steal your work. If need be, you can also just rename the page number itself by double-clicking it. Boom! Now I have my name in one place, two places, three places. And this is very much a more thoroughly tested work to be able to prove that it's yours in case someone steals it. Now then, I have my name on it. That's good. Now, the first thing we're going to have to do is, and I'm just going to double-click for text here, is I'm going to make myself a legend. Because whatever I decide the images that are going to be for this tic-tac-toe flowchart that we're going to make live in class, I need to make sure that people understand what is what. You know, you saw that bad flowchart example in the previous video, didn't you? If not, I recommend you go back and watch the previous video. First way to not get a good grade in this class is to not follow along. Because when you don't follow along, people don't hand things in because they get confused. So, if by any chance you're at this video and you have skipped all the other videos, go back and watch the previous videos. So, what is the point of the legend? The point of the legend is that I'm going to have certain things, and I want to make sure they're all consistent. I know I'm going to have at some point in time in this program a start point. And I know I'm going to have at some point in time an end point. And I know that those start point and that end point are going to look different than the other two. So, what else can I have? Well, there's two possible things that can always happen with any computer program. I can have output. Output is from the computer to me, so I'll tell you what, I'll even just name it computer output. And I know I can also have player input. And I know I will also need a conditional logic of some choice. And I'll just put that as a condition. Now, once again, because I have everything over here, when there's any sort of item that you have, you know, you can go and change stuff about it and make it all left-aligned or right-aligned, so on and so forth. I'm just going to keep and make this aligned like that, so that I can now just match up this legend with whatever it is I'm going to make. So I just like making the circle. I like making that green, just for the sake of, you know, that's a start point. It looks like a green means go. And same thing over here. I just like making this hexagon shape red so that I can then go and say that that is the end point. And computer output, I don't know, I'll make that a no real distinct reasoning as to why I'm making this a gray box, but I've decided I'm making it a gray box. I like having the diamonds being my conditions because I like just being able to easily see one thing going down and one thing going to the side. And my player input, you know what, we'll use a parallelogram on this one, which I can't remember if that's technically a rhombus or a trapezoid. That would be a rhombus. So technically it is a parallelogram, but it's also literally a rhombus. So whatever one it was that I didn't say, and I'll just make that orange. So now I have distinct shapes and distinct, you know, colors for anyone that's colorblind. So, okay. So we know we're going to have a start point. So let's actually just make a start point. And I'll make it green, because I said my start point was going to be green. So, game starts. So we know we have ourselves a game of tic-tac-toe. And we know we're going to have ourselves, somewhere along the lines, you know, game ends. And we know that we're going from game ends from game start to game ends. We know we're going to wind up having from this to this in some manner or fashion, using a bunch of outputs, inputs, and conditions. So, we're going to assume that this is a one-player game, and that this is a game with a computer as the second player. So, what is it that the player does when the player makes a choice in rock, paper, scissors? What is the one thing the player does? Well, they pick either rock, paper, or scissors. So I will have them say, pick rock, paper, or scissors. let me use proper parentheses there. Pick, rock, paper, scissors. That's literally the one thing the player can do. So, at some point in time, from the game start, we're going to go, boop, pick, rock, paper, scissors. That is something we know is going to happen. And now, what's the one thing the computer does? The computer will also obviously pick either rock, paper, scissors. So, com picks rock, paper, scissors. And you know what? I'll even be more specific. Randomly picks rock, paper, scissors. Because realistically, if you're inputting the controls into a game, the computer knows what you've just picked. And you'll see that in a bunch of fighting games where the computer knows exactly what you played and will thus automatically know the perfect counter on harder difficulties. It's cheating, it's unfair, so we're making it random. It will randomly pick rock, paper, scissors. So no matter what you pick, it picks something random. And that's really all there is to this game. Player 1 picks, and you know what, I'll even just name this player picks rock, paper, scissors. So, the player picks and the computer picks. We have right here with us 2 variables. What are variables? Variables are places to store information for later use. Because now in this code, now that we have these 2 choices saved, we're going to compare them. So, the way I'm going to do that is with a chain of conditional logic. So, boop, boop, I'm going to ask a very simple question. What is it that you can pick in rock, paper, scissors? Well, there's going to be 3 options. Did player pick rock? That's one question. Did player pick paper? That's another question. And did player pick scissors? Scissors? Whoop, 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 whoop. Sensitive mouse. There we go. So those are our 3 possible things that our player could do. And I'm just going to stack them one on top of each other like this. And once again, don't worry about moving things up and down. That's perfectly a-okay. It will automatically make us stuff like this. So obviously, there's that question, and then this question. Now we'll get back to this question right here. So, did player pick rock? I'm going to say if yes, I'm going to go over to the side. Okay? So if yes, something's going to happen. And if no, I go down to here. So now we have ourselves another question. Because now we know player picked rock, yes. There's something else that we need to worry about. Did the computer pick rock? Did, the computer pick paper? And did the computer pick scissors? We've got ourselves essentially 3 statements each that we have to worry about. Did computer pick paper? And did computer pick scissors? Whoops. And there we go. So, if the player picked rock, and the computer picked rock, well, obviously, what winds up happening then? That would be essentially information letting us know that there's a draw, right? We would let the player know that we're showing a draw. We would literally print out the word draw for people to see. So we know that that's a possible outcome. Now, so if we have, so following along, did the player pick rock? Yes. Did the computer pick rock? Yes. Therefore, we got ourselves a draw. But if no, did they pick paper? So let's follow this logic along. Did we pick rock? Yes. Did they pick rock? No. Did they pick paper? Yes. So we have paper and rock. Well, if we have paper, if we have rock and they have paper, well, then that means we lose. And obviously, if they didn't pick rock and they didn't pick paper, well, then they must have picked scissors. It's the only option. And this is why I said we'd get back to this guy down over here, because this guy right here is the only option. The only other potential option, if they pick rock, no. They pick paper, no. Well, in that case, do I even need to really ask this question? Did Com pick scissors? No, I didn't. It's the only option. It's the only other possible choice. So, let me put something here that says win. You know, we'll let the player know that they win. So I'll put a no there, and boom. And that's basically one potential branch of rock, paper, scissors. Now let's just, mosey on down here. Boop. And I'm gonna do this again, and you know what? I'm just gonna select all of that, copy it with Command C, and paste it with Command V. So now we got a chance to check this out. So did we pick rock? No. Did we pick paper? Yes. Well, since we picked paper, did they pick rock? If yes, is that a draw? No, that's not a draw. We picked paper, they picked rock, we win. Okay? So we picked paper, they picked paper. That's not a lose, that's a draw. And which means our only other option here is lose. And let me just keep scrolling this guy down here, and I'll scroll this guy down here, because we don't even need this other potential option, because the only other option is scissors. We did not pick rock, we did not pick paper, we picked scissors. So, and one moment. I'm going to, can I pause this? How do I pause this? One moment. Be right outside. Okay, my apologies for that, but as far as you guys have probably already guessed while staring at this screen, no, I'm not going to actually go back and do any sort of editing on this, is that if we have ourselves a situation of the player picking, obviously picking scissors, did they pick rock? Well, if the computer picked rock, that means we lost. If they picked paper, that means we win, and if we wound up having ourselves a draw via two scissors. And now we have essentially breaking this down into a game of tic-tac-toe. Now, here's where we could just have each and every single one of these things just wind up going down to the game ends option. I'm going to do something else instead. I'm going to have the computer ask a question. I'm going to have the computer, at the end of this, say, play again. We're going to keep it go. We're going to keep this program going. And if we pick no, well, then obviously then the game will end. But if we pick yes, and this is where we purposely designed this in such a way that things don't fold over each other. So even if every single one of these things winds up going in to this option right down here. So even if every single one of these options winds up going down to the question of play again, if we pick yes to play again, well, then we're just back up there. And let me just move this over here. Boop. So if we want to play again, if the answer is yes, there it goes. We go right back up to the very top, where we pick rock, paper, or scissors, because that's essentially the start of the game. And this is just how we break down all 9 possible outcomes. Excuse me, I thought I did you. There we go. And that's how we would break down all 9 possible outcomes. Rock to paper, rock to scissors. Paper to rock, paper to paper, paper to scissors. Scissors to rock, scissors to paper, scissors to scissors. The all 9 possible outcomes of oh sorry, I put this as tic-tac-toe. This is not tic-tac-toe. This is obviously rock, paper, scissors. I've been calling it tic-tac-toe the whole video, haven't I? Well, that's great. This is the cursed video, obviously. But, yeah. Have all 9 possible options of a game. And what do we have here? We have conditional logic branches. We have ourselves technically a loop. We go back up here every single time until we decide to end the game. Nothing is crossing, nothing is overlapping, everything is going to where it said it needed to go to. You don't get lost. We have ourselves a legend. We have ourselves a title. This is a functional game of of rock, paper, scissors in the game in flowchart format. This is what our code could look like if it was represented by graphics instead of line-by-line code. And this is the type of concept I want you guys to understand of what comes first, what comes second, what comes third, and in what order it goes to. Because could you imagine if I had play again, if I had it asking me play again in between when I pick and when the computer picks, well, then that means all of this would get screwed up. Be play again, go back here. Play again, go back here. Play again. When I say no, then suddenly it goes and the computer, keeps going and that's what happens? Well, that doesn't make sense. So, making sure that your order of operations is correct. You have the things going in a logical standpoint, And there we go. That's basically a game of rock, paper, scissors in a flowchart format made from beginning to end in, 30 minutes with a phone call. So, yeah, when you are done with something like this, file, remember to save, because we always need to make sure everything's saved, and also export this, please, just in case you lose it. If you export it as a PNG, this grid background will wind up being transparent and it might cause issues. So save it either as a JPEG or as a PDF. And export it and it'll go and ask me some questions. Selection only, crop, grid. Include a copy of my diagram, transparent background. We're going to leave that all off. Export. And it'll go and ask me, what do I want to name this? And I'll go and name it, whatever it is. I named it already, so I had it named as class example.draw.pdf, so on and so forth, and I'll save it to my device. And it's thinking about it. Boom, there went the little bouncy thing. And I have the draw.io, and I also have, right now, here's what my diagram wound up looking like. And because of the way pages are, it cuts it off different ways. Hence why, we also don't talk about Uno, because if it goes across pages, it'll drop down, so information that's attached to page 1 is on page 3. So going vertically is easier than going horizontally, but horizontally can be done as well. And I could have probably tightened this up to actually make it all fit on one page. But, it is a functional flowchart. And now that you've done this, you've done the follow along. Your assignment should generally look like this. If it does not look like this, then that means you've missed something. Please go back and watch the video again. And thank you very much. I love you. Sorry, that was what the phone call was from, so I have that stuck in my head now too. So yes, I love you too, class. I do. I love all of you. So you guys have a great day, and you have a lovely day. And I'll see you in the next video. Thank you. Bye-bye.